Hello, it's me and Lovebug. This is Jane with Second Wind Nation. I'm on here to give a quick tutorial over some more math. We'll be covering the quadratic equation, the quadratic function, the standard form, and the actual formula. We'll also be covering squaring, how to complete a square will be the meat of it. But right now we want to go over some basics dealing with the quadratic function. The quadratic is basically a way of graphing, finding points on a graph with using a formula. It's necessary when you're dealing with physics, dealing with anything linear, dealing with anything scaling models for stock market behavior. You can also use it to build homes, to architecture type endeavors and things of that nature. Anything dealing with masonry, if you are interested in architectural masonry, mechanics in a sense of building, or we call the type of work dealing with math that heavily depends on accuracy. Everything from flying jets to getting out in the outer space uses this exact math that you would be learning from me on tonight. Along with more math, of course, but we'll be touching on some of the meat of the math that's actually being used to implement models to go by to get exact, precise distances or things of that nature to make sure that everything's right. So right now we're just going to focus on the quadratic equation and go from there. Right now we'll work our way down the sheet, and you will see here I have the quadratic equation already wrote out at the top. It is a to the nth power, well, I should say it is a to the x to the nth power plus b. It could be minus here. It's just standard information here on how the rule to go by when you're formulating from polynomial type equations that you need to come up with a formula for or whatnot, or graphing or anything like that. So as you can see, it's a, b, c, and it equals to 0. That would be the quadratic equation itself. It has a leading coefficient of no less than 1. In other words, the leading coefficient can never be 0. It has to be 1 or more than 1. And then that would be allowed to have a, as long as the x going with the a nth root is bigger than any of the other coefficients. Now these two terms together, all of this means is a term, and these are coefficients to each other. They're together. This is a constant, so it's a convenient thing that that's already a c, that's shown to be a constant. Okay, so we're going to go down the line here and we're going to write the quadratic function. They're a little bit different from each other. So this is the quadratic equation. It equals out to be 0. In your school is usually called the standard form. The standard form is usually a little different in a proper sense. It would be a little different from this here. But the quadratic function starts off a little different. We're going to use that fx on here, and it's also going to have a leading coefficient of at least 1, no more than 1 is necessary, but it cannot be less than 1. It has to be at least a 0. Now this one already has an equal sign. You notice that I stopped right there. That when I stop right there, because I started off with the equal, we're looking for the function of x. In a sense, that means y. So when you see these two terms, all that means is the y-axis on the graph that comes out as a result of the function of this, how you say, equation. So whatever comes out of here winds up usually being here if you eliminate x and make x a 0. We'll get into that a little later. That's a little bit more in depth, and so we'll take some time on that later. Now the standard form this is the proper way to write the standard form. Now remind you, it can have a higher leading coefficient, so or nth degree to the variable. The variable is just it's only, all it is the unknown. Whatever you see a letter, that's usually mean an unknown. We're usually wanting to solve for it, and eventually throughout the actual process of factoring and getting to the answer, which is going to be here, the constant. So normally we want to separate these two, this and this. At the end of the day, we're wanting to get this isolated, so that way we can say the x-axis equals 2 or the y-axis equals 2. So that's usually where we're going with that. So basically, don't try to remember this. As long as you're one that does your math on a regular basis, it will come to you. You'll get where it'll be no sweat. You'll notice that would definitely be something that kind of sticks with you after using it so long. So practice makes, how you say, skill. So practice makes skill here. So this is a skill that's very useful in all facets of dealing with business transactions, all the way to how we were talking earlier, the mechanics of a masonry, involving skill levels for models in masonry and architect and whatnot. So basically what we're going to do here is talk a little bit about this here. This is our quadratic function. And all it is a way of factoring when you can't factor. Say like you have a formula like this, and you need to get it factored down into those two binomials we were talking about. If you hadn't seen yet, refer back to the video just before this one to understand what we're talking about as far as the what we call polynomials. Polynomials are a way of getting points on a graph. So we're going to detail more later at